Hey guys, here are the notes for section 7.4. Let's get to them. Today we are going to learn, you're gonna really like this if you follow along. We are going to learn a better, what is going on there? A better, more efficient way to graph a linear equation. Let me just get started here. Up until now, we have been graphing equations by making a table of ordered pairs. And that's been kind of a pain in the butt, hasn't it? Then we plot the table of ordered pairs on the graph and we connect them to make a line. So we're going to do an example of what we've been doing just to see that it's not that great a way, perhaps. So we made the table by putting 1, 2, and 3 in for x. And then we came over here and we put 1 in for x. And we solved this thing for y. So I got -2 plus 3y equals -12. And I added 2 to both sides. And got 3y equals -10. And I divided by 3. And I got -10/3. Or if you like a decimal, that's like -3.3. Well, that's a yucky number to graph, but so be it, that's what I got. And then I went ahead and I put 2 in for x. And I solve for y. So this gives me -4 plus 3y equals -12. And I add 4 to both sides. And I get 3y equals -8. And I divide by 3, and I get y equals -8/3. Or if you like a decimal, that's -2.6 repeating. And then finally, I'd put 3 in for x. And I'm just going to kind of do this one mentally. If I put 3 in for x, this would be -6. And I'd get -6, and I'd get -2. There we go. So those are my 3 ordered pairs, and then I have to graph them. So the point 1, -3.3, that would be graphed by going 1 to the right, down 3.3. Let's see, 1, 2, 3, 3 might be about right there. Kind of an estimation, though, where 3.3 is, right? And then 2, -2.6 would be 2 to the right and down 2.6. So that'd be about right there. And finally, 3, -2. That one's easy. Over 3, down 2. There's my 3 points. And I can draw a line through those 3 points. And maybe it would look something like this. Let's draw it in a different color. So maybe it would look something like that. And I've graphed it, but that's a lot of work. And so what we're hoping to do today is to learn a new, faster way to graph. And let's get to it. Wouldn't it be nice if there was an easier way to graph a linear equation? One that did not require so much work. Well, there is. And we're going to slowly learn how to do it. We could graph a line by knowing any point that is on the line and the slope. It's really pretty easy if you know these 2 things to graph a line. For example, let's say this point is on my line. And let's say the slope is 1/2. If I know these 2 things, if I know a point on the line and I know the slope, I can graph the line like that. Here's how you do it. You start by graphing the point, -3, 1. So that's 1, 2, 3, 1. That's right here is the point -3, 1. And then the slope gives us directions to the next point. Here's how. Remember, slope equals rise over run. So I can use the rise over run to get to another point on the line. my slope is 1/2. So the top number in the slope is telling me how much to go up or down. And the bottom number in the slope is telling me how much to go to the right. This is telling me to go up 1 and right 2. That is what a slope of 1/2 is telling you to do. So I start at my point that I already know is on my line, and I go up 1, right 2, right? Up 1, right 2. And I can do that as many times as I want. Up 1, right 2. Up 1, right 2. And my line is practically drawn for me. So let me review that real quick. Right? Start at the point that you know is on your line. Use the slope to make more points. Let's practice that a couple times. So we're going to do 3 graphs here, all the same. If you want to pause the recorder and try to do them yourself and then come back, you're welcome to do that. But this is really important to learn how to do, and once you learn it, it's so easy. All right, so the first one, I'm going to do the first one in red. First, I put a point at -4, -3. That would be right here, right? 4 to the left and down 3. What is a slope of 2/3 telling me to do? Well, it's telling me to go up 2 and right 3. So that's where I'm going to go. I'm going to start at my point that I already have and go up 2, right 3, up 2, right 3, up 2, right 3, and look how fast I just drew that line. That line took me like, what, 10 seconds to draw? Let's try another one. How about this line? This is a line that has the point -2, 4 on it. So first we graph the point that we know is on the line. -2, 4. And from there we use the slope. Now this time the slope is -1, 3. The top number is a rise of -1, but when you rise negative, you actually go down. This is actually telling me to go down 1 and right 3. You guys, the bottom number always tells you how far to go to the right. The top number could be up or down, but I always go to the right with the bottom number. So I'm going to start at my point, and I'm going to follow these directions. I'm going to go down 1, right 3, down 1, right 3, and that's good enough. And there's my line. This last one has a new twist I want to point out. I'll do it in green. Okay, first of all, this point is on my line. It's the point 0, -4. And the slope is 3. Now, the slope is not a fraction, but I like it to be a fraction, right? Because the slope is equal to the rise over the run. I want the slope to be a fraction so I know how much to rise and how much to run. So when the slope is a whole number, I make it a fraction by putting it over 1. And now I have the rise and the run. This is telling me to go up 3 and go right 1. So I start at my point and I go up 3, right 1. Up 3, right 1. Up 3, right 1. And I have graphed that line. I hope you think that's fairly easy. But wait, you say those aren't equations. It's easy to graph it when you know a point and the slope, but what do you do when you have an equation? Well, that's what we have now. We bring this all together. Wouldn't it be nice if we always knew a point on the line and the slope of the line? Well, here's the good news. When an equation is solved for y, All right, that's what you did on your homework last night. You solved equations for y. Then the equation is said to be in what is called slope-intercept form. This is actually a formula. It's called slope-intercept form, and in general, it looks like this. When an equation has the y by itself, then you know two things about the graph. All right? We know that this number right here in front of the x will be the slope of the line. And we know this number out here will be the y-intercept. This will always be true when the y is by itself. So let me write that in down here. You know two things. The coefficient of x, right? This number is the coefficient of x. That's the m. Will be the slope of the line. You'll automatically know the slope of the line. It's whatever number is the coefficient of x. And this number out here that's not attached to the x, that's called a constant. That's the b. The constant term, the b, will be the y-intercept. So when an equation has the y by itself, you automatically know two things. You know where it crosses the y-axis, and you know the slope. That makes it really easy to graph. Let me show you. This equation has the y by itself, right? And since the y is by itself, I know two things. The number that is not attached to the x is the y-intercept. Oops, I meant to do this. The y-intercept of this line is -1. So I automatically know this point right here, -1 on the y-axis, that is where this line crosses the y-axis. That is a point on this graph. And here's the slope. The coefficient of x must be the slope of this line. So the slope equals 2/3, which is telling me to go up 2 and go right 3. So I start at my point that's on my line, and I go up 2, right 3, up 2, right 3, and I have graphed the line without having to make a table and do all the calculations. Let's try a second one. In the second one, and again, if you want to pause the recorder and try to do a couple of these yourself and then turn it back on and see how you did, you're welcome to try that. Number 2, what is the y-intercept? Where does this line cross the y-axis? Well, it's this number out here, right? The y-intercept is always this number out here that's not attached to the x. In this case, the y-intercept is 4. There's where this line crosses the y-axis. The slope of this line is -3. Now, -3 is not a fraction, so I'm going to make it a fraction by putting it over 1. And what is that slope telling me to do? It's telling me that this line goes down 3 every time it goes right 1. The top number is telling me down 3. The bottom number is telling me right 1. So I would go down 3, right 1. Down 3, right 1. And I have drawn the line. You gotta love it. All right, so 3 and 4. Can you look at these equations where the y is by, this only works when the y is by itself. When the y is by itself, the number in front of the x is the slope. So in this case, the slope, what number's in front of the x? I hope you know that even though there's no number there, there is. It's a 1. The slope is 1. And the y-intercept is the number not attached to the x. So to graph this line, I'm going to start at the y-intercept and put a dot. We always put the dot at the y-intercept first, then we use the slope. Now again, 1 is not a fraction, so I'm going to make it a fraction. And a slope of 1 is telling me to go up 1, right 1. But you say, oh no, I can't go up 1. I'm out of graph. I mean, I guess I could go like here. But you know what you're allowed to do? If you don't have room to go up 1, right 1, go the other direction. Instead of up and to the right, go down and to the left. Same thing. See how those make a line? Down and to the left, down and to the left, and you get your line. Last one. Now this one, I kind of reversed the order. This is the way we've been writing equations for tile patterns. Starting amount plus how many more tiles there are each time. So this would be like a starting amount of 5 tiles, and the amount of tiles are going down by a half a tile each time, if this was a tile pattern, right? Even though it's reversed, can you name the slope and the y-intercept? Right? The y-intercept is the number that's not attached to the x. In this case, it's 5. And the slope is the coefficient of x, so the slope is the negative 1/2. So how would I graph it? I would start by putting a point at the y-intercept, which is 5, and I would use the slope. The slope is telling me, well, it's negative 1/2. All right, you guys, I always put the negative on top. So I consider this to be negative 1 over 2. Technically, you could put the negative on the top or the bottom. I just think it works better if you always have the negative sign go on the top. And a slope of negative 1/2 is telling me go down 1, go right 2. So I'm going to go down 1, right 2, down 1, right 2, down 1, right 2. And there's my graph. I hope that helps. I think we're out of notes. Good luck on the homework. I'll see you tomorrow.